Hello everyone. First of all, I want to give thanks to organizing committee for giving us opportunity to present over here and especially through the virtual mode. In our paper, the title is Mapping First to Third Wave Transition of COVID-19 Indian Data by a sigmoid function. Main objective of this paper is to identify spreading patterns of COVID-19 virus and its three dominant variants by simple algebraic expression of sigmoid function. So this is the pattern of sigmoid function. As we all know that from 2020, WHO declared this coronavirus disease as a pandemic, and from that time to till now a huge amount of work are attempted by different authors to fit the COVID-19 infected daily cases and cumulative data. But one of the successful model is SIR model. Though another alternative model also used or method also used like regression analysis and population ecology to fit the data. But in this paper, we have used the sigmoid function framework for predicting Indian data of coronavirus. This is the main function, mean sigmoid function, n of t equal to n0 e to the power lambda t divided by n0 e to the power lambda t by nm plus 1. So here n of t depends on three parameters n0, nm and lambda. So n0 is the initial number of cases from where the cases start to beginning, and lambda is the growth parameter for which the cases started to increase, and nm is the maximum value where the case is saturated. And if we do derivative, that is the dn dt, we will get the lambda n0 e to the power lambda t divided by n0 e to the power lambda t by nm plus 1/3 whole square. Here dn dt represent the daily cases, number of new cases per day. So here we are seeing that the case is increasing exponentially. After some time it reaches the peak value, and after that it starts to decrease. And this depends on the initial number of cases n0, maximum cases nm, and the growth parameter lambda. Here this slide represents the TP. We get TP from this equation log nm by n0 by lambda. This TP is the peak time where the daily case reach its peak value, and it also depends on the maximum values of the cases in m and n0, that is the initial number of the cases. So we took these two functions to plot our data in the first wave, for the daily cases and the cumulative cases. And here n of t, the sigmoid function we took, and the its derivative represents the derivative daily cases in the first wave. The approximate in the first wave, the maximum value reached 1 crore in India. And similarly in the second wave also we use these two functions, the sigmoid function into t and its derivative function dn2 dt, and this nm2 reaches its maximum value. Approximately it was 2 crore in the second cases, and this n of t also depend on the same things, the n2 maximum cases and the n02 to the initial cases. Here also we plotted daily case and the cumulative cases. For the first wave, we select some states like Maharashtra, Andhra Pradesh, West Bengal, Tamil Nadu, Kerala and Karnataka, for which we plot daily cases and cumulative cases data respectively. And in this table, we had given the details values of each parameter. What we basically use, that is the lambda, nm1, n01, tp1 and DNDT. Here it is the peak value of daily cases. And in second wave also we select some states, that is the AP, Andhra Pradesh, West Bengal, Maharashtra, Tamil Nadu, Karnataka, Kerala. And here we also plotted the daily cases and the cumulative cases. And in table we had given details value of each and every parameter. In this slide, we plot different mutated virus in together, that is the COVID-19 Delta, Delta Plus and Omicron virus. And this solid line represents the daily cases and dotted line represents the cumulative cases. Here we are not seeing the beginning from the zeros, because we plotted all virus, mutated virus in one slide. And we are seeing that that for every virus in daily cases, the peak is increase. The daily cases increasing exponentially. After some time, it reaches into the peak, and after that, it starts to decrease. But we didn't get the value below 1000, because when the one virus start to decrease, and after some time, when the second mutated virus is generated, it start to increase. So we for each and every in between two virus, we got some overlapping zone or crossing zone, where first virus started to decrease and second virus started to increase. So we got this overlapping zone in between two viruses, that is COVID-19 and Delta, similarly between Delta and Delta Plus, and in between Delta Plus and Omicron. Here in this slide, we get the approximate value of the parameter individually. For COVID-19, lambda was approximate 0.04, whereas it was just twice for Delta virus 0.08 and thrice for the Omicron 0.12. And maximum cases it was 1 crore, and for the COVID-19, and in the cumulative cases, and for the Delta it was 2 crore, and the Delta Omicron it was 1 crore. And TP was for the COVID-19 it was 192 days, for the Delta it was 96 days, and for the Omicron it was 134 days. And daily cases at in peak daily cases it was 1 lakh around for the COVID-19, and for the Delta virus peak daily cases was 4 lakhs around, and for the Omicron it was around 3.3 lakhs. So, in summary, we can say that the present work is intended to explain the existing first, second, and third waves of COVID-19 infection data with the help of simple logistic function. And it is very interesting that entire COVID-19 data of India can be easily understood by simple algebraic functions, algebraic expressions of the sigmoid functions, and we can identify 4 sigmoid patterns due to COVID-19 virus and its 3 dominant variants. Thank you.